Now let's look at 2024 AIME II Problem 15. This problem gives us a regular dodecahedron, so it's a regular 12-gon, okay? And it says that we want to use it to construct rectangles such that each side of the rectangle is either a diagonal or a side of this 12-gon. It asks us to count the number of such rectangles. So we will use this diagram for our analysis, okay? So how we count the number of rectangles? It really depends on your perspective of how you want to construct a rectangle. So the perspective that I take in this problem is that every rectangle is determined by two pairs of parallel lines, such that these two pairs are perpendicular to each other. So let's think about how we draw a rectangle. So the first pair of parallel lines may look like this. And then we need to have a second pair of parallel lines that are perpendicular to the red ones. Once we have these four lines, a rectangle is determined. So we will use this perspective to solve this problem. Okay? All right. So for all these lines, so let's check about their positions. So their positions are determined in terms of the slopes, right? So let's see the slopes of our possible lines. Okay? So we have the following observations. So also let me define the following concept. So for any two vertices on this 12-gon, how I measure their distance? So we know this separates the 12-gon into two parts, the minor arc part and the major arc, right? So I will compute their distance by looking at the minor arc. So here in this illustration, we look at the upper half, right? And see what is the number of vertices that are strictly between these two endpoints. So in this example, there are 4 such points. So then we say that the distance between these two red points is 4. And let me give you another example. Let's say these two. So there's only, if you look at the minor arc, there's a single vertex between these two. So the distance between these two is 1. And for these two, there's no vertex between these two. So we say that distance between these two is 0. Okay? So this is the first notion I need to define here about the distance between two vertices. And the next thing that we can do is, because for this rectangle, so every side comes from either a side or a diagonal of this 12-gon. So we should try to connect any pair of vertices in this 12-gon and see about their slopes. So how many possible slopes do we have? So we have the following observation. Okay. I'm claiming that. So we define the distance in terms of whether it is even or it is odd. So let's first look at the odd distance. So that could be 0, 2, and 4. Okay. So I'm saying that. So suppose we look at a line that has or a segment that has distance 0. Okay. Like for instance here. Then when we make the translational move, so we will have this one with distance 2, and this one with distance 4, and the next one with also distance 4, and this one with distance 2, and the last one with distance 0. So we can see that for each given segment with distance 0, so it corresponds to a family of parallel segments, right? They have the same slopes, but just with different length. Okay? So given this fact, then when we want to determine the slope of a segment whose the distance between two endpoints is even, so we just make translational move to move it to a side of the 12 count and see what is the slope of the side. Okay. So this can significantly simplifies the number of cases. And now let's see that for all segments with distance 0, which means that for all sides in this 12 count, what could be the possible slopes? So we start from the bottom one, the slope is 0, and then when we move to the adjacent the edge, the slope is increased, where the angle is increased by 30, right? And for 12 sides, so we can put them into 6 groups, right? So each side has its opposite one. So these two have the same slopes. They are parallel, right? So we only have 6 possible slopes. So for the bottom one, let me use K to denote the slope, 0. Then the next one to its right is 10 of 30. And next one, 10 of 60. And the next one is vertical, so it's 90. So the 10 of 90 is infinity, right? The next one is 120, 150. So we only have these 6 possible slopes. Okay? All right. So this is a list of slopes for a segment in the 12 count, such that the distance between 2 endpoints is even. Okay? And then let's look at the scenario that the distance between 2 endpoints on this 12 count is odd. So such distance could be 1, 3, and 5, right? So what would be the possible slopes for all this family of segments? So let's look at this one. I'm claiming the following fact. So finding other tangents could be boiled down to just find all possible tangents for segments with length 1, which means that there's just a single vertex between 2 endpoints. Let's see why. So given this one, so we can come up with a family of segments that are parallel to this one. So for instance, if you make translational move, we get the first, the blue one. So it has length 3, where the distance between 2 endpoints is 3, right? Then the next one. So the distance between 2 endpoints is 5. You move up, then the distance between 2 endpoints becomes 3. And the last one, the distance between 2 endpoints is 1. So basically, when you want to measure the slope of the diagonal or segment in the 12 count, such that the distance between 2 endpoints is r, so it can always be boiled down to computing the slope of its parallel segments, such that there's a single vertex between 2 endpoints, which is the red. So now the problem boils down to count or list all possible slopes for such diagonals where the distance between 2 endpoints is 1. Okay? So we may start from this red one. So we know this angle is 15 degrees. Okay? So all such case could be from 15. So here it should be 10 of 15. Okay? So I just drop off 10, but I refer to 10 of 15. Okay? And what is the next one? So for the next one, you make the rotation here, right? So it increases value to 30 by 30, so it's 45. The next one is 45 plus 30 is 75. And it's plus 30 is 105. And the next one plus 30 is 135. And the next one is 165. Okay, so we have these 6 possible slopes for this family of segments. All right, so after identifying all these features, we are now ready to count. So let's look at the red one, because here's the thing. So to form a rectangle, right, we need to choose 2 types of lines. Their slopes, so they should be perpendicular, which means that their slopes should have the multiplication that is equal to -1, right? So we can easily see that when we choose these 2 pairs of lines, so they must be either both from the red class or the blue class. We can't have a pair of parallel lines from the red class, a pair of the lines from the blue class. Otherwise, there's no way for them to have the intersecting angle that's 90. No one, right? And for each color class, say the red class, so for those 6 possible arguments or the slopes, so actually we don't have to discuss all of them. So we can do the case for analysis. For instance, in terms of these 3 values. Why? Because think about it. Suppose the slope of one pair of lines takes the value in the yellow group. Then the other one should have an argument that is equal to 90 plus a number from the yellow group, right? So we could use these 3 numbers in the yellow set to do the casework analysis to define each case. And also the same thing for the blue group. So for this group, we can define each case in terms of its argument, who takes the value from this yellow set. And once we pick up the argument from the yellow set, what about the second pair of lines that are perpendicular to those who are from the yellow set? So we just increase the values of these angles by 90. That's it. Okay. All right. So now let's do the casework analysis. Let's look at the red group first. And for these 3 possible numbers, 0, 30, and 60, if you look at the diagram, actually, there should be no difference. For instance, if I ask you to count, say, okay, so now we have 2 groups of lines. So one pair has 2 lines that have the slope 0 or argument 0, and the other 2 lines that are perpendicular who are vertical. So for such a position, you count the number of rectangles. It should be the same as the second case, that the first pair of parallel lines have argument 30, and the second pairs of parallel lines have argument 30 plus 90 is 120. So we just make the rotation, but nothing's changed. Therefore, for this group, we only need to count for this case, and then we multiply by 3. So that includes all 3 cases. Okay. So let's look at a scenario case equal to 0. So now the problem becomes that in this diagram, we need to find a pair of horizontal lines and a pair of vertical lines that form triangles. How many triangles we can form? We'll make the construction in the following way. So first, we'll determine 2 horizontal lines, and then we'll insert vertical lines. But this brings us an issue. So let's look at this scenario. Say for 2 horizontal lines. One is this one, another one is this one. So suppose we choose these 2 horizontal lines. How many vertical lines we can select? Then we know that although in this 12-gon, we have 6 vertical lines, but we cannot select all of them. Why? Because, for instance, if we select the leftmost one, we can't get a rectangle inside the 12-gon. It's not good. So what are possible vertical lines? It must be this one. Right? So how their width or range is determined? It's determined by the width or the length of the shorter horizontal one. Right? Okay. So given this fact, then even for the case that k is equal to 0, so we need to do some additional casework analysis in terms of the length of the shorter horizontal one. So regarding the length, we know there could be 3 numbers: 0, like this one, 2, like this one, and 4, like this one. Okay? So let's do those casework analysis. So suppose the length of each one. So let me copy and paste again. This is for case 0. Suppose the length of the shorter horizontal line say where the distance between two endpoints is called 2i. So we know I can be 0, 1, or 2. Okay? So given such I, first we need to compute what is the number of horizontal paired lines. So how many pairs do we have? Okay. Suppose say this one is the shorter one. So this corresponds to I is equal to 4. Okay. How many pairs of horizontal lines? All right. So first, there's one scenario that the second horizontal line has the same length as this shorter one. So both two horizontal lines have the equal length. So this is one scenario. And plus the second scenario that two horizontal lines have distinct length. In this scenario, so in the first step, we need to decide that whether the upper line is shorter or the lower line is shorter. So there are two possible choices of which horizontal line is shorter. And given this, suppose say, okay, the upper one is shorter, then what is the number of the second horizontal line? So now we require the second one to be below this one, and it should be longer than this one. Okay? So here we see that if I is equal to 0, so the number of choices is 1, 2, 3 is 4, right? If I is equal to 1, like this one, so the number of choices of the second line is only 2, right? So it should be 4 minus 2i. So if I is 2, so we can't find a horizontal line longer than this one. So this is the total number of combinations of forming a pair of horizontal lines. Okay, given I. All right, given I. So we know the shorter horizontal line determines the range of vertical lines. So for instance here, we know that for I is equal to 2, you can see we have 4 possible vertical lines, right? So there is actually this one, this one, this one, this one. And if I is equal to 0, we know that we can only have 2 middle vertical lines. So the number of the vertical lines is equal to 1. So the number of possible choices here we have is 2i plus I, right? So we can select the 2 vertical lines from this number, and we choose 2 vertical lines. So this is the total number, okay? And then we sum over I from 0 up to 2. So this gives us the total number of rectangles that we can form by using one pair of lines that are horizontal, one pair of lines that are vertical. So by doing some algebra, this number is equal to 50. And recall that for the scenario that a pair of lines have the argument 30 and 60, so this should generate the same number of rectangles like as k is equal to 0, right? So for the right case, the number of rectangles is this number, okay? All right. Next, let's count the second scenario that the argument of each diagonal over the side, actually there's no side, the diagonal in the 12 gon is 15, 45, or 75. Again, all these scenarios are the same. So we just need to count the one that we have one pair of lines whose arguments are 15 degrees. Okay? All right. So again, first, we need to decide about for such pair of 2 parallel lines. So what is the length of the shorter one? Okay. So we know that so its value can be 1, 3, or 5, right? Again, so this number measures the number of vertices between 2 endpoints. But here's an issue. So 1 refers to this case is 1, then the next one is 3, the next one is 5. I'm saying that we only need to consider cases that the number of vertices between 2 endpoints is 1 or 3. we only need to consider 5 case. Why? Because for the 5, it's a diagonal, right? So it's the longest diagonal. So if this is shortest, but we can't find another parallel diagonals that have equal or longer distance, no way, right? So we don't have to consider this scenario. So we only consider scenarios indexed by 0. Let me call them 0 is equal to 0 or 1. So the number of vertices between 2 is 2i plus 1. Okay. All right. So now let's look at each scenario indexed by I. And let's first decide what is the number of pairs of parallel lines that have the slope with argument 15. Okay, given I. So first, suppose we consider this one. So this corresponds to I is equal to 1, right? So the number of vertices between 2 and 1 is 2 times I plus 1 is 3. So first, we have one scenario that 2 parallel lines are with the equal length. So we have one such case. And next, we consider a scenario that 2 parallel lines have distinct length. So we need to decide that where's the shorter one? Either it is below the longer one or it's above them. So there are 2 possible choices. And for each possible choice, like what you see here in this illustration, so the shorter one is below the longer one. Okay, so then let's count what would be the number of longer ones. So here, for I is equal to 1, we see that, so we have just the single longer line. That is the longest diagonal, right? So if I is equal to 0, then we have 3 such lines. So this quantity is equal to 3 minus twice of 1. So this is the number of pairs of parallel lines with argument 15 degree. And next, given this shorter length, how we come up with the number of the pairs of lines that are perpendicular to this one. So how many such lines that we can choose from? So we need to choose 2, right? How many we choose from? So for this case, right? So we know that what we can choose are essentially this. So you see that for I is equal to 1, so you have 5 possible blue lines to choose from, right? Okay, and what about let's say I is equal to 0? So for I is 0, so basically this is the shorter line, and we only have the middle 3 blue lines to choose from, right? Therefore, this number in the binomial term is 2i plus 3. All right, and then from this quantity, it corresponds to I, each particular I, and then we need to sum over I from 0 up to 1. By doing some basic algebra, its value is equal to 51. And for this case, don't forget that this corresponds to the argument is 15. So we also have the scenarios for 45 and 75, but they should give us the same number of rectangles as 15 degree. So for this case, the total number of rectangles is 51 times 3 is 153. Okay. And then we put 2 cases together. So recall that in the first case, the number of rectangles is 162. In the second case is 153. So the total number of rectangles is equal to 315.